Hi. This video is about subtracting integers. In previous videos, students have done work identifying integers and building integers using zero pairs. And that building integers with zero pairs work is going to be very important for this lesson. Students have also done adding integers with the algebra tiles. And when they added the integers with the algebra tiles, they noticed that sometimes they actually ended up with less than what they started with. So this idea of linking subtraction and adding the opposite has already been set. So in this video, we're going to do some samples of some questions we can ask students to do with subtracting integers, and we'll talk a little bit about how that helps them develop the rule on their own. So let's get started with some examples. So we're going to start off with a very simple subtraction problem. We're going to start with positive 8 minus positive 3. And we know students already know the answer to this. But what we're going to do with this example is to show what the idea of subtraction actually means and how to use the materials with this. So when we have positive 8 minus positive 3, we always start with the first number, representing that with the algebra tiles. So here we have positive 8. Now instead of representing the positive 3, what we're going to do is we're going to take that many away from the group. So we're going to take away 3 positives and just move them to the side for now. Our final answer is going to be whatever we have remaining here. So in this case, it's going to be positive 5. Just what we would expect. Here's another example that we can do. Negative 9 minus negative 3. Now what's interesting about this example is that usually we don't subtract negatives until much later on, but with the materials, this is going to make a lot of sense. So just like when we had the positive minus a positive, we're going to start with our first number. In this case, it's negative 9. And now we're going to take away or remove 3 negatives, or negative 3. So we put those to the side. And what do we have left? Negative 6. Here we have positive 6 minus negative 3. So we'll start off in the same way that we did for the other subtraction ones. We start off by making our positive 6. And now we have to subtract away negative 3. In other words, take away 3 negatives. But we don't have any negatives here to take away. But that isn't a problem if students remember the very first lesson we did with integers. We were able to represent integers in many different ways. So this is one way to represent positive 6, but if we remember that we can add a zero pair and not change the amount, then this is still positive 6. And indeed, we do have a negative here, so I could take that one negative away if I wanted to. But that's not going to do us enough good. We need to take away 3 negatives. So if we make 3 zero pair, this number that we see is still positive 6, and the students should be used to seeing this and reading this as positive 6. Now we can take away those 3 negatives, and we can see what we have left, positive 9. So positive 6, take away 3 negatives, or negative 3, equals positive 9. Here's another example, negative 3 minus negative 5. And so we'll start with negative 3. And now to take away 5 of the negatives, students will do this in one of 2 ways usually. And both ways are very good. The first way that they'll do it is they'll say, well, I need to take away 5 negatives and I only have 3. And so what they'll do is they'll put on 2 more zero pairs. They'll then take away those 5 negatives. And they'll see the answer is positive 2. So that's the first way they might do this. The second way is once they have their negative 3 here, they may just look at that negative 5 and say, oh, I need to put 5 pairs of 0 out here. So there's my 1 zero pair, 2, 3, 4, and 5. And then they'll just take away these 5 negatives. And then they'll see what they have left, and then they'll make the zero pairs They have 3 zero pairs here to take away, and they're left with positive 2 once again. The first way is obviously much quicker, but the second way actually gets to the heart of what they'll be doing when we're talking about adding the opposite, and we'll see that in a little bit. As students work through more and more examples on their own, they're going to see that the same thing is happening over and over again. That what they're doing is they're adding on the number of zero pairs to whatever it is they want to subtract. Once they subtract away what they want, they end up combining together their original amount plus the opposite of whatever they took away. So they're going to see that every time they're doing a subtraction problem, they're really adding the opposite. And as students work more and more, they're going to be getting faster and faster at that. And some of them may come up with that rule on their own, and others, when we see them working in the right way, we can help them along. So let's look at an example of how a student might make this transition from doing it the long way to shortcutting to this rule that they have discovered. When students first do positive 7 minus negative 2, they'll probably put the positive 7 out, and then they'll try to make their zero pairs. They know they need 2 negatives, so they'll put out 2 pairs, a negative and a positive, and then they'll subtract away the 2 negatives, giving them positive 9. But as students get faster and faster with the work, they're going to see what's happening over and over again. Instead of putting out the whole zero pairs, instead of putting out the entire zero pair, they're just going to take these negatives away anyway. So rather than put them out and take them back, they'll just put the 2 positives out right away. And that's when we can make the connection that taking away these 2 negatives is really the same as adding 2 positives, which is what we saw in the addition work actually, that taking away is the same thing as adding the opposite. So what we can do is we can revisit those original questions again, but with the idea of subtracting as adding the opposite in mind. For those students who have kind of discovered that on their own, this is a good way to reinforce that. For students who are still working a lot and kind of struggling to see this idea, then we can revisit this lesson again, but ask the question in a new way. So when we revisit positive 8 minus positive 3, we can put out those positive 8 like we did before, and say last time we actually had to physically remove these 3. But is there another way to make those 3 go away? And the answer is yes, we could add 3 negatives. And by adding 3 negatives, that's going to have the same effect, because those are going to cancel with 3 of the positives, making those zero pairs, and what we have left is our positive 5. So when we add these negative 3's, that has the same effect as subtracting away. And we can see that very clear with the materials. So if we were to revisit negative 9 minus negative 3, what we did before was we put out 9 negatives, and then we took 3 of the negatives away. But is there another way to get rid of these 3 negatives? Yes, we can add 3 positives on. And by making those zero pairs, that in essence takes away those negatives, and the positives go away anyway with the zero pair. So again, I can get the same result instead of actually removing these 3 negatives by adding these 3 positives. So throughout all the examples students have been doing, they're seeing this link between subtracting and adding the opposite. And that's very powerful. We don't have to actually give them that rule. They'll come up with it on their own through the work. And if students aren't coming up with it on their own, then we can give them more examples, ask them questions to help them get there on their own. And that's very powerful for the students to be able to do that. If they ever forget the rule, they can draw pictures. If they're in the classroom, they can go grab the materials and recreate that experience for themselves once again. And every time they do that, it'll come back faster and faster until the students truly have mastered subtracting integers. So that's it for this lesson. I hope that you enjoyed it, and next time we can do some multiplication with integers. Thank you very much.